In case I haven't had the opportunity to introduce myself to you yet, my name is Justin Solomon, and it's my pleasure to moderate this evening's panel, as well as one this afternoon and this morning. So the theme of our panel for this evening is all about data visualization, in particular understanding urban and electoral data. The basic concepts that we're trying to get at here is that really visualizing and understanding what goes on in cities is insanely critical to understanding a lot of the challenges in addressing gerrymandering. In particular, there's obviously a lot of concentration of particular political beliefs in cities, as well as just a very high population, a very high concentration of people that we have to figure out how to split up. So in order to split these folks fairly, you really have to understand something about the anatomy of a city and how people interact with it. Without further ado, I will introduce our first speaker here, who's Ariel Mdange Fupfu. So Ariel studied physics at Stanford and got an engineering PhD from Northwestern. For the past 2 years, he's worked at Data Incubator, which is a data science education startup focused on hands-on learning. Besides designing and optimizing data workflows and tackling software engineering projects, he spends time on curriculum development and instruction. Ariel believes in the importance of data science literacy and communication skills both for practitioners and stakeholders, and sees visualization as a big part of that skill set. So with that, I will give the stage to Ariel.
Thanks, Justin. All right, can you guys hear me all right? Cool. So yeah, like Justin said, I'm all about hands-on learning. And what I want to talk to you today about is how to actually build tools using open source technologies that are out there free for anybody to use. You might have noticed from my bio is that I've constantly gone from more theoretical to more applied. So I really like just the part where you actually get to build stuff. And what I want to show you in a bunch of code, which you don't really have to pay too much attention to, is how easy it is to use a language like Python to make a visualization tool that lets you visualize location-based data. So why Python and why Folium? Folium is the name of a package for Python, which we're going to be using. Python is really all about plugging into a whole bunch of different technologies. I like to talk about it as the minivan of programming languages. It's not the sportiest and it's not the most compact, but you can throw whatever you want into Python and it will get you to where you're going. So what we're going to go through is a really quick demo that I threw together over the past 2 days that shows how we can throw in mapping from Leaflet, API calls to open transit APIs in Washington, DC, and web hosting with Flask and Heroku to actually make a little, to do a couple different things. To do a bus tracker, so we're going to look at some live bus locations. We're going to make some choropleths based on census data, and we're going to lastly look at some walk score data from the walk score API. So again, the takeaway here is not really the details of this. I'm going to push all of this up to GitHub. I'm sure the link will be made available to you somehow. And all this stuff is on the internet, so you can look at it there. But I'm going to show you how all these pieces kind of fit together to make a tool that you might end up actually giving to somebody to use. So, blah, 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 lots of motivational stuff up here. So let's get to the fun part. A lot of what we want to do in mapping is geocoding. So there is a Python package for that. It's called Geocoder. And we could call like a geocoding API, but this is a perfectly fine way to do it as well. And you can see that I can plug in a location, like for example, DuPont Circle, neighborhood in DC. And I can actually just say, hey, Geocoder, go use the Google geocoding service for that string and give me back this location object. That location object has a latitude and longitude, also has a Geojson, has a whole bunch of stuff associated with it. So once I have that location object, I can go to Folium, my mapper, and say, hey, Folium, make a map with the location at that latitude and longitude. And so just with a few lines of code, I can get a map that looks like this, right? So this is an interactable map. I can scroll it around, and if my internet connection holds, different parts of the city will load. I can zoom in, and because this is OpenStreetMap data, you can see it's very rich in terms of what's actually there. And yeah, this is DuPont Circle. So this is just one layer that I can build on. So in the interest of time, I'm not going to spend too much time on any one of these things, but this is one of those things I wanted to point out in terms of how we plug in now maybe some outside data. So what I did is I went to the WMATA website. WMATA is the Washington Metropolitan Area Transit Authority, and they have an API. Justin talked about urban structure. Well, cities are at the forefront of making their data publicly available in rigorous and robust ways. And Washington, D.C., New York, Chicago, San Francisco all come to mind, where you can just go and get huge quantities of variety of data very, very easily. What an API means is I can just structure essentially what is an HTTP request to this website at wmata.com, and I can give it some info like I want buses around this latitude and longitude and such radius. And I can provide it this input, and the output it gives me looks something like this, some JSON object with a whole bunch of buses. And you'll see if you dig inside this JSON object, well, here's a bus at this latitude and longitude. It's going kind of west on Route 96. And if I run this code again, it will get some new data. I mean, we can do that right now, because this is live code cell. And live demos are always fun. So what happens is that I can then go through and use a for loop or something and take all these bus markers and put them on the map. So now I have locations of where buses are on this map. There is something very powerful about doing this. You can easily get carried away and just keep calling it more and more live data. A lot of what we want to do when we actually build these tools is be very careful about the load that we're putting on these services. So you'll notice here that I am doing what's called checkpointing, and I'm actually not going to call the API again if I think I already have that data. That's what this refresh equals false means. So if I change this refresh equal to true, then it's going to actually query the API for some new data, and we can plot that and see that now the buses are in different locations now because I updated it to right now. So this is a very simple idea, but it's very powerful, and again, probably something that you can build on. You can add more information on top of this. So some of the other things that Folium can do, Folium is a wrapper around the leaflet.js library. It's a JavaScript mapping library you're probably familiar with. What you may not know is that Leaflet works really well with Geojson. Geojson is very similar to the shapefiles you may have been hearing about. A lot of GIS data comes as a shapefile, which is basically something which is kind of like this, where you have a whole bunch of coordinates here which kind of delineate a polygon, and then you have some data associated with that shape. Geojson is just another form for that. So there are tools to convert back and forth between these as well. So if you have a shapefile you'd like to use with this code, by all means, use an online tool to turn that shapefile into a Geojson, plug it in here, you'll see it on the map. So besides the shape, you can see that this particular Geojson I'm working with has fields like area, it has fields like perimeter, POP90, which is, I believe, the 1990 census population numbers, poverty group, poverty rate, et cetera. And because we have shape data correlated with values, now we can start doing whatever data analysis you want. Here I'm just going to use Python's pandas package, which is basically a data frame, rows and columns, to go through and do, make some derived columns based on maybe density, because I think population by itself is not that relevant, but the density is more interesting. And then whatever values I come up with, I can set up a color map to kind of represent the scale of how that value changes. And again, just skimming through this, you can take all of that, that value data that you have and plug it onto this map. So that looks something like this. you can see that I can tick on or off these layers. So I can tick on poverty rate, I can tick on population. I've plotted population in blue, poverty rate kind of in red, purple, so that you can kind of see where they overlap. So now you can like see at a glance, oh, here's some areas that are kind of purplish. That means they have high population and high poverty rate. Or here's some areas that are just dark blue, high population, but poverty rate's pretty low. So you can do a lot of analysis very quickly with this kind of technique. And obviously I could go further. I could take the buses and overlay that on here. I could do all sorts of things. What I thought might be kind of interesting was to look at walk score. And I'm not sure how much time I have left, but cool. So walk score is just this kind of proprietary measure of how walkable a location is. One thing that I thought about as I was putting together this bus demo was what's between bus stops? I think about maybe we put bus stops in populated places which are probably pretty walkable, but what's between those bus stops? Do the buses go over like a desert, or are they just going among lots of populated areas? And it turns out that WMATA has data on their API that give you basically the entire shape of a bus route and not just the stops. So that's what I'm doing in this next part. I'm taking the entire shape of a bus route, again, calling another API, now the walk score API, to get a walk score for every point along that bus route. And again, using caching, because I really don't want to piss off the walk score people. You can see I'm very careful about branding here, so don't take away my API key. What I can do is then plug in a route, again, an input, and get some data out. So here's a walk score, bike score, transit score. Their transit scores aren't very good. And so what that might show me is something like this, where, okay, well, here's a particular bus route in DC. I can tick, again, these layers on or off. I plotted on a different background map this time, because maybe terrain is kind of more interesting when you're looking between bus stops. And so this is Rock Creek Park. Not a lot of people living in Rock Creek Park, not a lot of shops in Rock Creek Park, so the walk scores are lower. And you can kind of see that here. And obviously I could do this with lots of different routes and stuff like that. So again, I just wanted to show you kind of what's possible here. It's not very complex what I'm doing. It's just a matter of taking these disparate data sources and disparate technologies and plugging them into each other. That's the trick. One last thing I'll show, just as the cherry on top, is how easy it is to turn code like this into a web application that you can publish for anybody to use. The beauty about Python is that I can write my web application in the same language I did my data analysis in. So here's my web application. It's really hacked together. It's not super long, but this is basically, if you know a little bit of HTML, there's a template which has a form, and the elements from that form are passed into this application. I ask for a location, I ask for a radius, and I take that information and I set up my call to the WMATA API here. I draw my map using Folium, and then I render that HTML. So this is live right now on this site because of Heroku, which is a free web hosting service for kind of small, not production scale, but small apps. And this just works, right? I can type in, Logan Circle, radius of 1200. Obviously, I'm going to use cached data if I can to spare the API, but I could always turn that off. And what this is doing is behind the scenes doing all that stuff which I just showed you. And then it will generate this map that you can play with. So as this thinks about it, I'll stop there and ask if there's any questions, comments, snide remarks.
All right, let's thank our speaker. All right, so we're going to have a little bit of a ballet kind of thing here. So we're going to switch speakers up here. I'd like to remind everybody that they can ask us questions by going to tinyurl.com/askjerry, and I believe we'll see them there. Maybe while we're switching speakers, I'll go ahead and ask one question to start discussion, and then we'll have about 20 minutes to talk with the whole panel at the end, by the way. I probably should have laid all this out at the beginning. Right, so do you have any ideas for how to use these kinds of data to visualize or conceptualize a community of interest?
Yeah, well, it's all about finding either direct variables or proxy variables that you can use to kind of get at that idea, right? So if you're talking about a community of interest like, say, lawyers, that may not be very obvious or very easy to get on like census data, but you might be able to use OpenStreetMap data to find businesses that match certain things like bar, or figure out some way of getting at where lawyers might be. And then you might be able to, with some degree of certainty, say, I think that this area is a cluster of where lawyers are. Or obviously lawyers is not a very relevant example, because you don't care about that community of interest, but, or I shouldn't say we don't care, but they can protect themselves.
I'm not sure that protecting the voting rights of lawyers is our main priority.
They can protect themselves. But yeah, so a lot of what data science is thinking about what are the right features to use, what features can we use as indicators for things that we really care about.
Okay, excellent. Our second speaker is Maya Majumdar, who's an engineering systems PhD candidate at MIT and a computational epidemiology research fellow at Health Lab. Before coming to MIT, she earned a Bachelor's of Science in Engineering Science and a Master's of Public Health in Epidemiology and Biostatistics at Tufts. Her research interests involve probabilistic modeling, data mining, and systems epidemiology in the context of public health. She also enjoys exploring novel techniques for data procurement, writing about data for the general public, and creating meaningful data visualizations. As a freelance data journalist, she has recently conducted analyses on fatal police shootings and post-election hate crimes in the US. So with that, I'll let Maya take the stage.
Awesome, thanks. Hi, everyone. So I'm really glad to be here. As Justin just noted, I am a double jumbo, which around here means that I have 2 degrees from Tufts. I love this place, and I'm so excited that Moon and everybody that's organizing this conference is taking on such an incredible endeavor, and especially thanks to you guys for being here at now 7:49 on a Tuesday evening. So without further ado, as Justin just mentioned, I'm a computational epidemiologist, and in short, that means that I like to use news and social media, kind of novel, non-traditional data sources to better understand public health trends. So in public health, because that's my background in part, we believe that awareness is critical to enabling and ensuring public-centered action. So within the context of gerrymandering, my favorite example is citizen phone calls to state representatives. When they know that gerrymandering is a problem, they can be enabled to actually do something about it. And that includes not just, citizens of gerrymandered districts, that includes all of us. So because of this, the questions I'm most interested in when it comes to gerrymandering are a little bit different than I think what a lot of the content of the conference has been about so far, which is pretty exciting. And for me, the real focus that I would like to place on my brief talk today is on awareness. How much do we actually know about gerrymandering as a population, and how heterogeneous or homogeneous is that awareness across the United States? And so with that in mind, there are 2 primary questions that I'm going to be kind of talking about with y'all today. So the first is, how does gerrymandering awareness vary across the United States? And if it does vary, does awareness of gerrymandering correlate with presence of gerrymandering? So ideally, we would hope that the most affected areas, the areas that have the most gerrymandering, would also feature individuals that are most interested or aware of it. But the real question is that really the case or not? So to address the first question, I used Google Trends data to assess gerrymandering awareness across the United States. Here's a map of the US broken down by Nielsen DMAs, or designated market areas, which we can talk about a little bit later if anybody's interested. And darker shades represent greater population adjusted search interest in gerrymandering relative to lighter ones. Google Trends data essentially serves as a proxy indicator for awareness. And this is a real kind of interesting source of data that my colleagues and I at Harvard Medical and at MIT have kind of been using probably for the last 3 or 4 years. And in general, it's a pretty damn good measure of how aware or how interested people are in a certain topic. When people Google about something, it usually means that they're interested or aware of it. So with that in mind, from this map, we can see that gerrymandering awareness varies considerably across DMAs in the US. But thinking back to question 2, it becomes kind of really obvious, the next question, I suppose. Is this heterogeneity that we're seeing in this map actually correlated with presence of gerrymandering across the United States. And so to address this question, I combined the aforementioned gerrymandering awareness data, this time at the state level, with state level gerrymandering metric data, and ran a quick regression analysis to see whether or not a relationship existed. So here we see a number of different visuals. At this point, I will note that these slides will be available online, so you guys can kind of click through and zoom in and see what's actually going on at kind of at your own pace, but I'll quickly run through these for now. So to the left is a multi-panel visual. The map up top shows population-adjusted search interest in gerrymandering by state, while the bar graphs on the bottom show various state-level gerrymandering metrics in shades of gray, matched against search interest in orange for each state. To the right are correlation charts for each of the 4 gerrymandering metrics shown, plotted against our gerrymandering awareness proxy for any state, with more than 1 voting district, so that's n equals 43 states. Polsby-Popper is shown top left, Schwartzberg is top right, Convex Hull is bottom left, and Rioch is bottom right. As is easy to see from these scatter plots, awareness of gerrymandering seems to actually be negatively correlated with presence of gerrymandering. In other words, states with more gerrymandering seem to actually be less aware of gerrymandering than states that have less gerrymandering. Though this relationship is weak, it's meaningful because it's the opposite of what we want to be seeing. So the natural question next is, why is this happening? Why are folks living in heavily gerrymandered states less likely to be searching for gerrymandering? And in general, what that really means is, why are they less likely to be aware of it? And how can we develop interventions that might mitigate the situation? I don't think we have an answer to this question yet, but my colleagues and I are working on it. One thing is certain, though, we have an awareness problem. Thankfully, the public-centered agenda to address this problem is pretty clear. First, we need to prioritize awareness campaigns in heavily gerrymandered regions. And second, we need to monitor and evaluate the progress of these campaigns over time and at multiple scales to assess which ones worked and, which ones didn't. The first half of the agenda is largely contingent on where we choose to spend our money, which is a bigger problem and bigger question that is better saved for another time. But when it comes to the second half of the agenda, one possible way to monitor and evaluate awareness campaigns is, again, once to turn more to Google Trends. In addition to offering geospatial trends, Google Trends offers data on temporal trends as well. So with that, we can start to assess the efficacy of different interventions that we might be placing to increase awareness of gerrymandering across the country. Here's a look at how search interest in gerrymandering has changed at the national level between election 2016 and present, shown in gray. Similar to the spatial data that I shared earlier, the temporal data shown here are adjusted against peak interest within the specified time range. As can be seen here, interest in our time range was highest on June 19th, when the Supreme Court announced that it would be taking up an important redistricting case involving line drawing in Wisconsin, which I'm sure many of you are aware of. And this particular case may have resounding repercussions for the rest of the country as well. Ideally, we'd like to see awareness campaigns prompt peaks in search interest similar to this. Granted, the national scale isn't enough to tell us about localized awareness interventions. So here's a look at how search interest has varied in Massachusetts, right here, overlaid, shown in orange, on top of the national search interest. Clearly, statewide interest adheres pretty closely to national interest over time, but if we take a look at June 22nd, which is kind of pointed at with this arrow here, we see that Massachusetts experienced a small secondary peak following the June 19th peak. And that's a peak that the rest of the US actually didn't experience. So this seems to coincide with an excellent piece that was published in the Boston Globe called "The Gerry Behind Gerrymandering." This, in my opinion, is a terrific example of how a more localized event or intervention can prompt a measurable signature in the search interest and awareness of citizens. As we start to think about how awareness campaigns should be designed to best meet the needs of those that are most affected by gerrymandering, I believe that tools like Google Trends and other non-traditional data sources provide an awesome low-cost alternative to more traditional intervention monitoring and evaluation methods. And on that note, I would like to extend my gratitude once more to the conference organizers and to all of you guys for being here. Again, I'll be posting these slides to my blog, and we'll be tweeting about that when I do. And I'll also make sure to talk to Moon about putting these slides up in a way that's accessible for everyone. So at this point, I'm happy to take a couple of questions while we set up our next speaker. And otherwise, thanks, everyone.
All right. Excellent. You guys are already swapping. So one quick question for you, Maya. So how different are gerrymandering awareness maps from just simple population densities? Like, do you think those things are correlated?
That's a great question. So one thing that Google Trends does is that it actually adjusts for population. So one thing that I personally really like about Google Trends as a data source is that a lot of kind of behind the scenes adjustment happens to kind of make it easier to compare, say, Iowa to Massachusetts, where you have different population densities, and you may even have different internet penetration levels. So in general, that's actually something that we're not so concerned about with Google Trends. One thing that I personally think is really interesting is that at least between election 2016 and now, Vermont has the highest amount of interest in gerrymandering compared to any other state in the US. Of course, Vermont also doesn't have much, if any, gerrymandering, because if I remember correctly, I think it's only one district. Now, with that said, it kind of really makes me think, and I hope it makes everyone in here think, you know, why do we see more interest in some areas than others, and what can we do to increase interest and awareness in places?
Great. So our next speaker is Mary Solberg. Mary is a GIS data engineer at Tableau Software, which is a company that's close to my heart because it was started partly by a professor that was in my lab at PhD. She received a master's in mathematics from the University of Washington, and her thesis was on mathematical aspects of gerrymandering. I think Mary also has a handout. I'll remind you guys one more time, that's in the back of the room there, so hopefully everybody has a copy by now. Mary, do you need a copy? I can run up and grab it.
Oh, no.
Okay, excellent.
I'll explain the purpose of the handout at the end. If you didn't get the handout, it's okay. So I want to talk about data visualization, which is kind of more my expertise. I want to talk about two things, which is how to do it at all. Because if you're going to get involved in this and you want to like try and explain things to other people, data visualization and sort of explaining the data to other people effectively is going to be really important. So how do you even get started with that? And then also some tips for how to do it well, or at very least not to do it too poorly, which is a little bit about what the handout is about. So first of all, tools. The tools that I personally would use. If I'm just given a data set, I need to figure out what is in the data set. Once I figure out what's in the data set, how do I explain that to someone else and start making some charts and graphs and so forth on it? The main tool that I would use is Tableau. Of course, disclaimer, I work at Tableau, so it's free. It could also be free for you if you go to that website and you get the Tableau public version. You just can't connect to databases, but if you don't want to connect to a database, that's fine. Or if you're an academic, you can get it for free. Or you can pay my salary. It's great. On the other hand, if I wanted to do something that was either more heavily statistical, or I wanted to do something where I'm doing the same analysis on 500 data sets, I already kind of know what's in the data set, and I just want to do the same analysis on 500 data sets, or probably 50, because there's 50 states, right? Then I would probably start moving to R and Python that he demoed. Then if I wanted to do something that had more heavy geographic stuff, like I wanted to do how much of this lake is in this state or something like that. At that point, I would possibly move to QGIS and Postgres, although to be honest, I'd probably actually still stay with R and Python. But a lot of like, you want to just make a viz quickly, you want to get started, I would suggest Tableau is a great place to start, and it's also a great way that someone else can take the same analysis you do and sort of dig into it and quickly figure out what you did. So I wanted to just sort of give a demo of Tableau so you can kind of see what it is. And then at the same time, also criticize what I'm doing so you can get an idea of what not to do.
Unfortunately, that's we're gonna have to cut our eyes off. Yeah, move the window a little bit.
I will move the window.
Projector problem. There you go.
Just a second.
Oh.
Know what I'm going to do? I'm going to make this shorter.
Perfect. Thank you.
There. Thank you. Yeah. So what this is this is a data set that I've actually downloaded from King County. King County is the county that I live in that contains Seattle, and it has all of the precincts in it. And I've combined it with another data set that has all of the voting results from 2016. And so I can just come here, and these are all of the fields, which if you're familiar with databases, you know what a field is, but it's in Excel, it's probably going to be one of your columns, or potentially one of your rows, depending on how you're organizing things. You think, okay, I want to do something with this. Well, I've got a geometry. That's always fun because geometries make maps, and maps are always pretty. And then I can say, all right, what are these? These are all precincts. This is apparently the Stevens precinct. This is the Twin Peaks precinct. Is that where Twin Peaks was filmed? Probably not, but very close. And then I can see, sum of count, and so I can double click on that, and this is great. This is a choropleth map of how much vote did we get per precinct. Now this is very visually appealing, and this is one of the, I would say, first lessons to learn about doing data visualization. Just because you can make a map doesn't mean you should. One thing, when you make a map, your eye is drawn to the thing that's biggest. Is area important when we're doing analysis of data? Probably not. Very rarely is area important. So if you just want to start talking about comparing votes and vote turnout or something, you might want to just come over here and say, let's just do a bar chart. And then immediately it does a bar chart that has the wrong size of everything because we're on a projector. And so you can make things a little bit bigger. And then you can sort it. And then you can immediately see, yes, this is the precinct that had the highest turnout, less highest turnout, etc. So this is kind of a nice thing why I suggest using Tableau if you're not sure what's happening in your data source, is it can quickly help you figure out, wait, what's even in there? And then you can be, okay, sweet, now I want to do it by party. I can put party on color. Why are we getting, I don't know what that means. And so then you can be like, okay, I'm really not understanding things, and maybe it doesn't really make sense for 30,000 people to be in a precinct. So we can click on it and look. I don't know if you're going to be able to see this because of the screen size. But once we look in it, we can see that race is not what you were thinking of it. It's what race are we talking about? Is this the US Senate? Is this the presidential race? Is this the various judge races? And so we're actually having all of the different races all combined into one, which is why it's actually really important to understand your data before you start digging into it. And it's second hardest part. The hardest part is actually getting the data. But the second hardest part, which is understanding what is your data even saying. Okay, so if we're like, okay, why don't we just focus on one race? Then we might say, okay, let's just say race, we're gonna bring that to the filters shelf and just find the governor's race. Governor, okay. And then now it's just the governor's race. And we can even say, okay, and we also want to, why don't we put party, no, we'll keep party on color, but why don't we also bring party to the row shelf? It's still formatted really weird because we're on a projector, but now it's like easier to sort of compare, and we can turn on labels. So that allows you to explore. Of course, the nice thing about the map, I said, the map area is not important. But what maps do is they help you figure out what are we talking about. When we're talking about precincts, we probably don't know what any of these precincts are. Having geographic context of where is this actually would be helpful. So what we can do is we can come over here, and now we can make our map. Put in the collection, sum of votes. Sorry, I'm just going to do a little bit of Tableau magic that I already know how to do. Apply to all of my worksheets. Sum of vote on color. And then I'm also going to put precinct on label and make that show up. I said show up. Oh. Yeah, there we go. And then cool. And now if I use this as a filter, I can sort of zoom down to what are the actual results. If I don't use it as a filter, don't use it as a filter. I can just highlight things or come over here and highlight, find out that this is just some tiny little precinct in there that I don't know about. So I'd say this is very good for exploration. So now to, again, come back to, okay, how do you actually do this well? Is this a good data visualization? This helped me figure out what was in the data really well, but some things that are wrong about this. One, my color choices. In some ways, my color choices are good, and in some ways, they're bad. I have chosen to use orange and gray. If I want to really emphasize I am nonpartisan, maybe that's a good idea, but these are Democrats and Republicans. So everyone knows those as blue and red. They're going to recognize your viz much more quickly if you use blue and red. If you want to like really emphasize I am not partisan in any way, you might make sure that everything else about your color scheme does not use blue and red. Another thing that's actually really important is all this does is tell you what the results are. It doesn't have a story in it at all. I made a nice viz a while ago, looks like this, that was the Brexit results, the EU referendum results. That was kind of the same idea. It allowed you to sort of click and filter and find out what were the results of every single little district. And that's really compelling right after the election when you just want to know what the results are. But in a sense, this is a tool, but it's not telling a story. So one thing you might want to keep in mind whenever you're making a data visualization is what is it that you're trying to say? And one thing that I might think is, well, if what I'm really trying to say is how does each district compare to all of the others instead of how is it by itself, you might want to, instead of using a bar chart, use something else like this is a little scatter plot, and then this still little highlight thing works where you can click and you probably can't see, but it's highlighting the little points in here that represent each one. And so you can, instead of seeing how each one is the hard numbers, it allows you to see how does it compare to all of the others. And which one you're going to show really depends on what story you're going to try and say. So these are not necessarily good examples, so I'm going to instead show you a good example that someone else made. This was a visualization that someone else made called The Art of Gerrymandering, 50 Years of Redistricting. Already from this, you know what it's going to tell you, right? It's going to talk about gerrymandering, and it's going to give you some history and put it in context over the last 50 years. One thing that you can say, well, good or bad, this has a lot of text on it. Gerrymandering, definitely, it takes more digging into and more context. So he's combined both visualizations and interactive visualizations. As you hover over this, it actually changes the little icon down there to give you more context about what this is. And so that's something that drags you in and makes you want to look at it. But right next to it is a block of text. And so figuring out how to balance those, where you're actually conveying the information, but putting something there that's going to drag them in, it's always like a hard balancing act. So this is like your classic cracking and packing thing. Then they come down here and tell a story of a single district. Now this is definitely a place where maps are appropriate because when we're talking about gerrymandering, the shape and size of the district is incredibly important. It's exactly what you're talking about. So maps are definitely going to be part of the story when you're talking about gerrymandering. And I think that this person did it very well where, one, you can see the whole thing, but as you hover over it, you get information about each district and you can see the history of it. Assuming that the numbers are actually like, if you're talking about the North Carolina District 3, is that the District 3 throughout entire history? It's debatable, but in a lot of cases it is. And then finally, he made a thing that allowed you to, again, choose your own, like dig into your own, and see how your district compared over time. So if you're curious about California, you could see all of California, or you could narrow in on the 44th and find out how the 44th district changed over time through various congresses. So this is both a tool that you can dig into, but it also definitely tells a story, right? It tells you this is the change of different districts over 50 years. It narrowed in on one district and told the story of it. So I think that this was a fairly good example of a viz trying to explain something about gerrymandering using visualization. So the handout, by the way, the handout is something that I use whenever I make visualizations and want them to be good. It just kind of gives you some things to kind of check and think about whenever you make a viz to make sure that it's actually on track and telling the story that you want to. So I just thought it would be a great thing to hand out if you want to get into data visualization. I've in the past found this very helpful.
All right, let's thank our speaker. All right, so I think I'll shuffle a little bit myself. No problem. All right, so I guess I'll ask you and then hand off the microphone. So one of the themes that we heard in a lot of today's and yesterday's talks in the mornings was also reflected in your talk, which is that you said the hardest part is actually getting the data. And so my question is, do you have any lessons from projects that you've worked on in the past that can help us encourage our efforts in the future in this particular direction?
In terms of getting the data, it's hard. I don't know. I mean, basically my job is for a company getting data and making it match with each other. That is like my job. Don't expect it to be easy. I guess it's just a lot to learn. You have to learn. Don't expect it to be easy. I think some people do come into it expecting it to be easy, but honestly, how you structure the data matters. Even if you get it from, the stories of getting data from counties, they're not supposed to charge you. Supposedly, like, whenever a county charges you for data, it's only supposed to be for reproduction cost. But a lot of counties are basically looking for any way to make up their budget, and so they will charge you. Getting data is hard, cleaning data is hard. Look for the tools that already exist. R and Python are great. Alteryx is another one that you have to pay a lot of money for, but is really good. It is getting easier day by day because it's something that people are focusing on, but just actually learn how data is structured. I don't think it's the best.
Just a second question popped up on our forum, which I think is quite easy for you to answer, so I'll hand it to you. What is a tooltip?
Oh, sorry about that. The tooltips, when I hovered over it, there was this little thing that popped up that gave some this is the racial makeup, this is the name of the district. That's called the tooltip. Sorry about using jargon.
All right. So Vanessa A Simple is a data visualization and mapping engineer and founding member at flippable.org. She's a graduate of UC Berkeley and a self-taught software engineer who has previously worked on Hillary for America's tech team and has held numerous positions working with GIS software applied to the environment, real estate, and earth science. Vanessa also runs the San Jose chapter of Girl Develop It, where she helps women learn how to code.
Thank you. Well, it's really an honor to be here. This has been a great experience, and I've met so many of you, and you're all great. So I just wanted to give a little disclaimer before I start. Most of the speakers at this conference have been really awesome at being very nonpartisan, but I'm going to be talking a lot about my organization, and we are very partisan, and so I apologize if we're not all on the same page with that, but I'm just going to talk about what our organization is doing, the problems we're trying to solve, and I want to show you the data visualization and map that it is at the heart of our mission statement and kind of go over our strategy and how it's based in this map. So I work with flippable.org, and it was born out of the Hillary for America campaign. Most of the founding members of our team all worked on the campaign, and after the election, we were kind of venting about what went wrong, what is happening with our electoral system, how is our democracy a representative democracy anymore, where the popular vote no longer meets the representation. And so we were like, what is the root cause of this? And we realized that it was state legislatures and the control that they have over voter suppression tactics and also over gerrymandering. And so we wanted to target flipping state legislature seats in chambers so that we can break up the majorities that are causing these issues. So at Flippable, our mission is to flip state governments from red to blue. State governments have the power to redistrict fairly, and they have the power to end voter suppression. I'm going to show you some stuff. Over the past 8 years, Democrats have lost 12 governor's mansions, 13 U.S. Senate seats, 69 U.S. House seats, but wait for it, we've also lost over 900 state legislative seats. And that's where all the power is in terms of drawing lines, in terms of voting laws. What happened was the GOP rolled out something called Project Red Map, and they were very open about it. Karl Rove even wrote an op-ed in the, what was it? Yeah, the Wall Street Journal, talking about how openly they were going to take state legislature seats, as many as they could, to control chambers, and so they could control the redistricting that would happen in 2011. It was a Hail Mary play, and it actually worked for them. They outspent the Democrats 3-1, and they took very strategic seats, took chambers, and there's a really, really great book on how Project Red Map was rolled out. I didn't even know he was going to be at the happy hour, and I got to meet him. It was great, but this is the book. I very much recommend reading it if you haven't read it yet, by David Daley. I'm not going to say the title. But yes, I just wanted to plug this book because it's a fascinating read if you want to know more about what I was talking about. So, one second. So what is a trifecta? A state trifecta is when all three branches of state government are ruled by the same party. So the three branches of state government are the governorship, the upper chamber, which is usually the state senate, and lower chamber, which is the state house or assembly. And so as of right now, this is the layout of the land in the United States. You can see that a lot of really pivotal states are in complete GOP control. And with the record of GOP's habits in redistricting and gerrymandering, if this maintains itself for the next census, throughout the next census, then they could pretty much like solidify the rules and to stay in power even though they don't have the majority vote. So we run into problems like how, for example, in the 2016 congressional races, North Carolina Democrats got 47% of the vote, but they only got 23% of the representatives, which doesn't seem fair at all. So yesterday, Steve Anselbert, I don't know if I'm pronouncing it right, said something really interesting to me that really resonated. He was saying that state governments, when they're making these rules, drawing maps, there's a process of negotiation where if one chamber is Democrat, one chamber is Republican, they have to negotiate and actually make fair rules because they have some accountability. But when there's a trifecta and all three branches are run by the same party, there really isn't that negotiation. And so gerrymandering is much worse under a trifecta. So Flippable is trying to strategically find seats to flip chambers to just break up some of these trifectas, especially in pivotal states. So state leg is an incredibly important topic. It's also incredibly complex, and it's not very sexy. So how do we get the point across to our users on why they should care and why they should support these races in states that aren't their state? Or just how do we get the point across of why this is important? And how do we keep it simple? So I think the biggest thing was that we needed to really show how close some of these state margins were, how many seats we need to flip, and that it's doable, so that people feel empowered and hopeful that this could be fixed before the next redrawing of the district lines. So we created this visualization that has been actually incredibly successful and shared, and people look at, and it's really brought our organization really far, which is just a really simple map. And the power of a simple map can't be understated. So this is called our State of the States. It's a simple map that shows the state chambers closest to being flipped and how many seats are needed in order to flip it. The states are colored on a ramp that is a function of how many seats are needed to flip the chamber and how many seats are actually in the chamber. So anything on the lighter side of the spectrum is closest to being flippable. And this is the basis of Flippable's mission and our strategy. So this is a simplified kind of mission strategy, and we have some tooltips here you pop up that our users can look at the map and say, okay, there's upper chambers, lower chambers, like how are these made up? How many seats do we need to flip? And so people can say, oh, how many seats in my state, do we need to flip? And they can get an idea of what is needed. So internally at Flippable, we add a whole lot more to this kind of data, analysis, we add a lot of layers to prioritize which states we're going to focus on. But it's good to give our users and empower them with the information to know exactly what we're up against up until for midterms in 2018 and for 2020. So looking at this visualization, where do we go from here as an organization with Flippable? So currently, we are focusing on the Washington Senate. We only need 1 seat to flip, and there's a special election coming up that could definitely flip that seat. Democrats actually have more seats in Washington, but some Democrats caucus with the GOP, which gives the power of the chamber over to the GOP, which is really interesting. So we're focusing on that, and then we're focusing, because in November, Virginia State House is holding all 100 House of Delegates elections, and we need 17 seats to flip, which is a pretty bit tall order, but this is kind of our test case on like how we're going to flip the chamber and how our messaging is. In 2018, because Wisconsin has some of the most restrictive voter ID laws in the country, for example, 9% of registered Wisconsinite voters don't meet the criteria for valid ID to vote. And so because they have a trifecta, because Scott Walker, the governor, is not term limited, then we need to flip their state senate, and we only need 4 seats to flip, so we need to make that a priority in order to make sure that future elections aren't, the future redistricting is done fairly. And then we have a few 1-seat pickups that we could do, like Colorado, 1 seat, Maine, 1 seat. So it's just kind of fun to play around with. And then also like the Virginia Senate in 2018, Virginia Senate in 2018, we only need 2 seats to flip. And so since the Virginia House and Senate have been GOP, but they've had a Democratic governor, the House and Senate came up with some really, really harsh voting laws, but the governor vetoed them because we have the Democratic governor for accountability. But they're going to be electing a governor later this year, and if we lose that governorship, then we're definitely going to need to take the Senate, or else Virginia might be a lost cause as well. So we're trying our hardest to politically solve these issues of gerrymandering and to bring some more balance to state government and break down some trifectas. So thanks for listening.
All right, so I think we'll maybe start with one question for our last speaker, out of fairness, and then we'll have some for the whole panel here. So Vanessa, maybe I'll ask a quick question for you. So we just heard in Mary's talk that one of the effective things that you can do is tell a story with your visualization.
Yeah.
Were there intentional choices that you guys made in designing this flippable tool to kind of tell the story that you wanted to tell?
Yeah, we have a few visualizations on our site. It's just one of them, and we add some context to them to try to tell a story, because we want to make sure that we are being inclusive to all of our users. A lot of our user base skews older and less technical, and we just want our visualizations to be as forthcoming and useful as possible. We got a lot of feedback early on from indivisible groups saying that they just liked basic maps with information, just so that they have it, because information and data on state legislature is really hard to find, sadly. So yeah, we like to tell as simple a story as possible and make it very accessible.
So, of course, the title of our session is all about urban and electoral data. And so what I'd like to ask each of you guys, and maybe we'll start with Maya and work our way in my direction here. Can you guys brainstorm some ideas for how to use urban data to think about how, like, the best way to fairly split a city?
Oh, isn't that the $1 million question, though? Huh.
Sorry, you have to go first.
Yeah, I know. Well, I can speak to this from my perspective. I think that Just to speak a little bit more about what we're planning to do with my team on awareness of gerrymandering, one thing that we're interested in is how the metropolitan split in states essentially informs the likelihood that the state population in general is interested and aware in gerrymandering. So I think that one thing that has gotten discussed a lot during the conference is that, cities are important, the people that live in cities are important. And part of my question is kind of flipping that on its head and being like, well, how do we bring some of the resources that are easily available in cities to people that don't live in cities? And I think that the internet is opening up lots of opportunities to do that. So for instance, tools like Tableau and Flippable, I think a lot of it is about actually targeting folks that don't live in cities so they know that these tools are available. And there are great ways to monitor and evaluate whether that's happening or not. So to me, that's kind of, it's almost an inverse response to your question, but I think that as important as cities are, and they are extremely important, I do think that by only thinking about them, we do a disservice to citizens at large.
Yeah, I definitely agree with that. Two things come to mind for me. One is that cities rarely look like the nice shapes that the mayors draw. Like if you go to this WalkScore website, which I alluded to, you'll see this like amorphous blob of green, and then it kind of fades out. I kind of think of cities as more like that, where the people are hanging out is kind of the city. So when you think about splitting up cities, do we split them up based on these political shapes, or do we split them based on these more organic shapes of where stuff is actually happening? The other thing that came to mind was, looking at groups. When you talk about groups and splitting cities, it's interesting to think about what are the shared interests of the people in that city, and you can look at this on a lot of different. From a lot of different perspectives. Like there might be people who have shared political interests, but there could also be people who have the same interest in getting the metro system to not be on fire all the time, or people who have the same interest in making sure that their local businesses don't get run out or whatever, making their neighborhood movie theater stay in business. I don't know, but you can look at all these things. Visualizations are a great way to look at those kinds of divisions on lots of different levels and maybe get a more comprehensive view of where to draw lines.
Yeah, I was just talking to my team earlier. This conference has really inspired me that it would be a really fun exercise to try to draw maps and kind of write about decisions that one would make in how to draw lines through cities, through more rural areas, and just what the thinking that goes into it to alert people to redistricting, gerrymandering, the fact that there are boundary lines, and just the critical thinking that goes behind it. And I think that it will lead to a more informed citizenry, which I think is really important. So it's not necessarily an answer to your question, but I think the analysis and thinking about it and talking openly about it, it's more interesting than we've given it credit for. And I think that the topic of gerrymandering is getting more and more popular to the point where we can just start actually publishing some maps and so that's really exciting for me.
So just from a very practical side of things, anytime you draw a line in a map, it's not actually very well defined. So if I was actually if I'm going to do this for a computer science reason, then it would just be oh, there's some fuzzy boundary between two neighborhoods. If I'm going to do this because I'm actually going to draw a district, I'm going to want to use a pre-existing line. So I would contact the city and say, give me every shapefile you have. I would turn that into a bunch of lines and try to figure out which of those are things that I could even possibly legislate on. And a lot of those are not. A lot of people are going to be oh, it's a neighborhood in King County, that's actually fine. We have different definitions of neighborhoods, and they don't agree with other people's definitions of neighborhoods, but they're actual lines. So if you're going to say this is where we should draw the line, if you draw it on something that is not actually defined and you just think is defined, you're going to piss a bunch of GIS people off. So not only is it a hard problem from a how would you choose what line to use? It's also a hard problem because you think a river is well-defined and it's not. You think a neighborhood is well-defined and not. You think a road is well-defined and it's not. Well, kind of. But, like someone moves an address and, definitely don't use postcodes. Postcodes are not, not actual things. So I have no idea.
Okay. Wow. No, you set me up very well for my talk tomorrow morning. That's great. So maybe we have one more nice question in here, and then we'll conclude our panel. And I don't know the best way to sort this so this is fair because you just gave a
It's
talk.
okay.
So we'll start on the
It's
other
okay.
end here again. So can you guys think of or describe any time where the data has your visualization has guided you in a direction that you didn't expect? For example, you set out to visualize or understand one problem and you realized while you were studying information that really the key problem was somewhere else?
Oh, I mean, all the time. I think that this idea of, coming up with a hypothesis that you're really committed to is sometimes antithetical to science. Keeping a bit of an open mind helps. But I think that actually going back to, how do we draw lines and stuff, one thing that I came across when I was actually preparing for this talk was this idea of, what kinds of scales of geography do I want to actually focus on? And at first I thought maybe I'll just focus on voting districts because that makes sense for this conference. And I ended up picking the Nielsen DMAs, which I did present, and there's a reason for that. So I think that sometimes private industry takes a different approach to things than the public sector does. And the Nielsen boundaries, the way that they're defined, are largely dependent on demography. So it's largely about what people will consume in certain areas. And given that we live in a capitalistic society, consumption of goods, whether it be TV or radio and so on and so forth, even internet, a lot of that kind of dictates what we think and what we do. So I think that opening up our minds a little bit to what types of boundaries we should be looking at is a really, really good idea. And that's something that I came across myself. And by incorporating the DMAs into my analysis, I think I have started to learn some things that I would not have thought of before, given where people consume what kinds of TV and news networks they have access to. These things are really important. Where you get your news from is often what informs your decision making when it comes to whether you call your state legislator or not, or whether you go to vote in a local election.
Yeah, for me, I try in all my data science to not have hunches that I then follow unless I'm specifically making a hypothesis. But there are lots of instances where you'll see something that's really unexpected and then you have to investigate that further, and that's kind of the point, is to have visualization as part of this feedback loop of, you can't spend all your time just exploring, you have to find those things to actually exploit, and visualization will help you identify those things. I do a lot of clustering. Sometimes, clustering, there's no right answer in terms of how many clusters you cluster the data into, which is kind of the fun part. So you can make plots which show different kinds of, different groups of clusters which you try, and you can see, oh, that's weird. When I use this particular number of clusters, I actually capture that little outlier group. So now maybe let's find out what that outlier group actually is. And maybe it's like a type of voter that acts in a very particular way, or maybe it's a type of shopper who acts in a very particular way. So yeah, that kind of stuff happens all the time. And if I can just say one thing which I forgot to say in the talk is that all the stuff that I showed is on GitHub at, if you go to GoToREL is the GitHub name. So just github.com/GoToREL and you'll get all that.
We'll try to find a way to share links to everybody's materials afterward.
I guess mine is more of a data access discovery. When Flippable started out, I had never really worked with precinct data before, and all the levels of spatial data that is around elections and things like that. So I was like, oh, okay, I'm just gonna dig in, and I became acutely aware of how much people are reinventing the wheel with data cleanup, and we were talking about this a little bit earlier about how precinct data changes so often and how it's just a thorn in everyone's side. And so starting out with Flippable, I thought, I'm just going to do a bunch of analysis, and I realized that it was actually more important to try to form coalitions to create data repositories and avenues where like organizations can work together to always stay on top of the data because there's not always a lot of access. So that's kind of like the avenue I ended up going into. And then you just mentioned the hatch. Were you talking about there's like a law that's being floated around? Was that you?
It was someone else, but I know about it.
Oh, okay. Which is really concerning to me is there's a law being floated around that the only spatial data that will be like considered for like the government and law will have to come from private entities and not the public, which is really scary to me. And it's like we need to work even harder to create open source communities in terms of this electoral data because it's already hard to find and it might become harder and harder and we just need to stay on top of it. So.
In terms of starting into data analysis and realizing that it's a very different story you need to tell, I feel like that's just kind of like what data visual analysis is. I guess it's like kind of why a lot of the products that are coming out. That's what Tableau was all about, is like, oh, you don't actually know what's in it. I feel like R and Python are much better when you already really understand what's in your data and you know what you need to write, and other tools for just sort of exploring are more for that. I wish I could find, I tried looking for this person. There's someone who does like sort of the paths of exploration, both in trying to find data, find things, searching for things, but also trying to find anything. And like the first step is like confusion. The second step is excitement, because you're like, oh, there's something interesting here. And then it's like the third step is like discouragement and depression. It's like, oh, there's just like, I can't figure it out. And it's just like, there's these like continual cycles of getting there. I think the challenge I usually have is trying to say, well, I need to just make something anyways. I need to present something, and sooner or later I actually need to give this to someone else. I really have learned something, even if I feel like I haven't learned anything. I need to just give it to someone else. I was just going to mention that the guy who made the viz that I made, Ken Farland, I think is his name, and you can get a link to it later. What he did is he just said, I'm going to make one viz a week. I'm going to just do analysis and actually make something I'm going to produce. I think that's actually really good discipline in terms of getting over that, because you're always going to discover something more, or your data set's not that interesting. There's a lot of data sets that aren't that interesting, but just actually like saying I'm going to make something and present it, that's really good practice. And like that viz that I showed you, he actually made that and has been like winning kind of awards after only a year of doing this. Like you're just like, I'm gonna make a viz for a week every year. And I feel like that kind of discipline of, yeah, it might not be anything like what I start out, but I'm just gonna do something, is actually just a really good practice.
Wow. Well, with that excellent advice, I think we'll end our session. Let's thank our speakers one more time.